Option C.
Okay, so I remember like I was basically starting a live solve with this on Saturday, and then like everyone, so I had like a minute, but a minute is enough to basically get the main idea in this question, especially if you're kind of in this mindset. This whole test has been algebra. Surely there's not another algebra question. Wrong. There's another algebra question. It's more likely the whole test is going to be more algebra.
Oh, wait, the solution to this one's just call A the number that repeats every 8 digits.
So if we look at this number here, where does it repeat? It goes to 9927, right? So this number here, right? Let's call that number A, yeah?
Yeah.
Okay. If you delete the A and make them all zeros, and then you have the number up to here, right? That number is 10 to the minus 8 times A. Is that right? Or is 10 to the minus something times A? Like, you know what I mean? Shifting it over.
It's A on the... You can just do A minus... Like, call N the, like, actual decimal thing. It's N minus N on 10 to the 8 is equal to A on 10 to the 8. Where that's A.
You know the fractal fractions?
Huh?
The self-similar fractions.
Right, let me just test this. So 1, 2, 3, 4, 5, 6, 7, 8 goes here, right?
10 to the 8.
Yeah, so it is 10 to the minus 8 times 8, yeah?
Yeah.
So can you see that this whole number is actually A plus 10 to the minus 8 times A plus 10 to the minus 16 times A plus, and then so on forever, right?
Yeah.
Okay, so this next part is actually, so I showed you guys this in class, but like in terms of the high school syllabus, this is not until like year 11 or something, right? The geometric series. So basically, like this number has to equal 1 over n, right? That's what we're looking for. Yeah? Okay, so 1 over n is equal to a outside of 1 plus 10 to the minus 8 plus 10 to the minus 16.
Yep.
And so on, right?
And you can just 1 to the... Yeah, and you can just do 1 to the n on 1 to the 10 to the 8n.
Yeah, so if you learn the difference of two powers factorization, you know how to deal with this. This is called a geometric series. Yeah? Hmm?
If you multiply the first thing by... Never mind.
Okay, so be careful here. A is not an integer, okay? A is like a...
Stop talking, sorry.
No, it's fine. What's wrong?
Never mind.
You get, like, so what you can do is, you can do 1 to the n, or 1 on n. Can we just call that, like, b for simplicity's sake?
Alright, it's not finished because people don't know how to add this up. Do you guys know how to, so I'll show you how to add this up, okay?
But, so you don't need
to
add this up. The idea you're getting is that you get, it's like factors of 999, right?
Yeah.
There's another way to do it that doesn't involve adding that up. Or it might just be enough.
No, I think in the exam, you're trying to avoid things you don't know, but when you're reviewing it, you're trying to learn as much as possible, okay? So, do people remember this? So this is a difference of two powers thing. So if you have x plus x squared plus x cubed, right? It can actually go up to any n, yeah? Well, let's say it stops at x cubed, yeah? If you do 1 minus x, okay? Can you see that equals to 1 minus x to the 4? You see that? It's because the 1 times everything gives you 1 plus x plus x plus x cubed, and then the minus x cancels all the stuff but shifted over by 1. Okay? So you start off with this, yeah? That comes with a 1, right? Then when you minus x, you're minusing, this gives you an x, this gives you an x squared, this gives you an x cubed, right? So then all these cancel, okay? And then this gives you an x4, which doesn't cancel, and the 1 doesn't cancel, right? So that's why it's 1 minus 4. You can do this for as high a power as you want. to x to the n, and you go 1 minus x, then it's equal to 1 minus x to the n plus 1. Okay? And so if you look at that here, what does that mean? Okay? Here, x is 10 to the minus 8, right? So it's saying this thing here, yeah, is equal to this thing divided by this thing. So it's 1 minus 10 to the minus 8 to the n over 1 minus 10 to the minus 8. Yeah? Okay, dokie. Okay, but the point is this goes on forever, yeah? This goes on forever. Okay? So there's not like a fixed value of n here. The n is just you can think of going on forever as having the n be really huge, yeah?
You can just bring n to the limit, right?
Yeah, so if you have 100 billion as your n, for practical purposes it's equal to this expression, yeah? But if you make n to the like 100 billion, then 10 to the minus 8 to the power of that is going to be essentially 0.
As you bring
Right.
n to infinity, 10 it goes to
Because
0.
you know, like 1% of 1% is like 1 in 10,000, right? So if you make 1% of 1% of 1% of 1%, it's going to be like basic. It's as close to 0 as you want.
Yeah.
Okay. So then if n gets really big,
You get to a.
okay, then this thing becomes 0.
Yeah, and then you get a.
And you just get a on 1 minus 10 to the minus 8. Okay.
Yeah.
Alright. So this is definitely like a I feel like this is like a targeted towards year 10, year 9, 10 kids. Okay, this kind of question.
There's another way to do it that's probably, or at least with simplification, that's simpler than this.
Oh, I would love to hear something simple in this. I'm very skeptical. Let's go.
Alright. So let's just keep A as the same thing, right? And let B be 1 on n. Just call 1 on n B, right?
Okay.
So then you can do B minus B on 10 to the 8 equals let's see, what does it equal? 1. Wait, does it? Yeah, it equals. Wait, no.
I mean, I feel like you're just stating the conclusion of this without proving it. That's like
No, because you let B minus B.
you didn't actually know where this went. So that's the problem that you have right now. So look, 1 on n, right? That's your b. Your b minus 10 to the 8 is literally just times in the denominator to the left side, okay?
Yeah.
So you get 1 minus 10 to the minus 8, okay, is equal to NA. Yeah?
Yeah.
Okay. So if your thing starts from there, then I don't believe it's actually simpler. Okay, it's just stated without proof. Okay. Okay, so this is what you get, right? So we're both gonna converge here anyway, right? Yes?
Yes.
Okay. Okay. So the problem with this expression is a is not an integer, yeah? What?
Can I show you that it is a factor of 999? Well, and that's how you say it.
But can't you see that that's what this gives you?
Oh, yeah, but it was like the different.
Yeah. Yeah, can you see how this gives you a as a factor of 99999? Huh? I think you still need to wait to the end of this because you're basically saying to me you don't understand this, which is kind of annoying.
I get this. I was just talking that out. Go ahead. Sorry.
Okay, so the problem is a is not an integer, right? Yeah. You times both sides by 10 to the 8 minus 1 equals n times 10 to the 8 times a, yeah?
Yeah.
Okay, so now it's an integer equation, yes? It's called a Diophantine equation, yeah? Everything's an integer. And so now you can show that n divides, so 10 to the 8 minus 1 is just 9 nines. It's just 8 nines, right? There's eight nines, yeah?
Yeah.
Yeah. Okay, so we can pick up from here after your explanation. So what's your explanation?
Okay, so basically, you have a sequence like a plus 10 to the minus 8, a plus 10 to the negative 16a, and so on, right?
So you're talking about this sequence here.
Yeah, so that's 1 over n.
Yeah.
So if you multiply that by 10 to the negative 8, you get the same sequence but without the a term. So you just subtract that from 1 to the n.
Yeah, exactly.
And you get 1 to the n minus 10 to the negative 8n equals a. So it's 0.9999999.
Oh, it's okay. It's a good idea.
Yeah, that's
Okay.
what I did basically.
Yeah, and you both missed the point the same way. Okay. So you've just proved this identity. That's all you've done. Okay. It's good, but it's not good if you don't notice that that's what's being done here. Okay. Right? Because that's exactly how this is proved.
Yeah, I know
right?
you're
You
doing
times
the
it
same thing.
and you shift
Yeah,
it.
I know
right?
you're doing the exact same thing, but this is
See,
like
I know
doing
you're
the
doing
same thing
the exact same
without-
thing, but this is just better. That's
Oh,
what
no,
he's
this
saying.
is just the exact same thing minus all the actual intelligent stuff.
What do you mean? That your thing is intelligent. It's the proof of this. But you got to realize that that's what it is. Yeah. So you can't just ignore this and say you did something. It's exactly the same.
Yeah, I know.
You didn't know. You know now.
I did know before.
According to him, he knew everything before. He actually is just realizing it in the class. He's not actually learning anything.
What?
Why is still here?
What do you mean here? Why not?
Okay.
Your father's
Okay. So n divides 8 nines. Yeah.
Yeah.
So actually, we did test in Saturday class that 73 actually divides 8 nines. Yeah.
Turns out there is a smart way to factorize this.
Whoa.
Okay, so our starting point of this problem now is now n divides something with 8 nines, yeah? Okay.
Yeah.
Something with 8 nines is divisible by 9 and it's divisible by 11, obviously, right?
So that's not. You need to express it as 10 to the 8 minus 1 to the 8. Think about it, sir.
Oh, that's not a bad idea, okay.
If you want.
Yes.
This is what Paula told me for the simplification.
Who told you?
Polar.
Oh, polar.
I'm not.
See, the difference of 2 squares, right?
Yeah. Plus 1.
Right.
And then you continue, and you get.
Then you get 10 squared minus 1 squared. 10 squared plus 1. 10
And
to
then
the
you,
4 plus 1. That's pretty good, right?
and you get. Yeah.
You get 10 minus 1. So we already know that. 10 plus 1. That's the one we started with. We knew that. Okay, and then 10 squared plus 1. 101. 10 to the 4 plus 1. Okay.
Yeah. And then you just divide the 101 by 137.
The 101 by 137.
Yeah. This is also equivalent to finding all the numbers, all the primes p such that the order of 10.
Hold on. We just slow down a second here. Okay, so we factorize this, so it's what is it like 9 times 11 times 101 times like 1. It's like 1,000, the 10,001, yeah?
Yeah.
Okay.
101 prime.
I can confidently tell you that none of them are even numbers.
Excellent.
And then we have 137 already.
They're not even numbers.
And then we have 101 already.
What? We have 101 already.
I mean 137 already. Which means we can just divide that one.
Yeah, because 137 has to be a value of a.
Yeah.
Why not a?
Okay, so what's this? Is 137
Times 73.
times 73. Oh, that's crazy. Okay.
Yeah.
Okay, and these are all basically prime except for 9, yeah?
Yeah. This is also equivalent to finding all the primes p such that the order of 10 mod p divides 8.
Oh yeah. Okay, so the question is if we had so how do we know we need like to pick out like a prime factor or something? Like why can't we pick like 3 times 11 or
Well, it's like the same number, but like halved or third.
huh?
Exactly.
What?
It's the same number of like it's the same number of digits in the sequence. I tried.
Just like
The
30.
same number of digits
So
in the
you
sequence.
just divide the sequence that you get.
You just divide the
The
sequence.
only one smaller than 7, like you get it over 11 is like 10101. It was like when you just divide by 11, it's like 90909. So, and when you divide by 3, you're just. That is what he's talking about.
He said, "What if? Why does it have to? He said, why does it have to be a prime?
Because the only non-primes smaller than 73 are multiples of 3 and 11.
Hmm.
And multiples of 3 and 11 that are less than 73 are all. Yeah.
Yeah, so I guess with enough time you can kind of just test a lot of these numbers, right? But how can we know for sure? Like how do we know? Okay, so we're looking for the smallest, that helps, yeah?
Yeah.
So if something small works. So like if you test 73 and it works, then you're kind of in a good situation.
Because it's obvious why 9 and 3 don't work. You just get 3, 3, 3, and.
Yeah, like they just repeat right away, yeah.
And then when you divide by 11, you get like 909, some number of that.
Oh, wait. Hold on. Wait, so is it true that... Hold on. So because you want to repeat it with 8, right?
Yeah.
Then it has to divide 10 to the 8 minus 1, yeah?
Yeah.
If you want to repeat it with like less than 8,
Because they already
then it divides 10 to the that minus 1. Is that right?
they divided the one that's like because 9 divides
Yeah.
9 and 11 divides 99.
Yeah, so basically you don't want it to be... Okay, now it makes sense. So you don't want it to be a factor of this necessarily, yeah? Because the factor of that gives you something which repeats every 4 times or less, yeah?
Yeah.
Does that make sense? Wait, does it say it repeats every 8 digits but not sooner, yeah? Yeah. So the ones that repeat sooner are like factors of this, yeah?
Yep.
Right? So you want it to be a factor of this. Does that make sense?
Yeah, because that's a smaller iteration.
Yeah.
Does that make sense, or am I just tripping?
No, that makes sense. They're not tripping.
Yeah, so then you have like... Then that literally eliminates 101 as well, right?
Yep.
That only leaves 137 times 73. And so we already considered 137. So, and only 73 is smaller.
Yeah.
Right? Okay, I guess that's kind of satisfying. I don't know, like it's increased to 5 marks. I don't understand.
That should not be 5 marks.
It's more punishing to the younger students, I think.
To be honest,
Nah, question 8 was so much easier.
8 should be 2 marks.
What?
Yeah, a lot of people got 8 right.